Hi everyone, my name is Naz and welcome to Building with Naz. In today's video I'm going to actually do something really fun, which is, not that the other videos aren't fun, but I'm going to implement a color gradient animation for a spinner component that I've been working on. There's another video that I did yesterday where I actually implemented 3 different variants of this spinner component, and it's all for a command line interface. So let me just show you this real quick before I get into the context. So this is the repo is actually Rebel Terminal Async. It's not been published to grace.io yet because still working on it. After today's after today's video, the other next big thing that has to happen is adding a bunch of unit tests. So that'll be yet another video because I've done an intro to testing video last week, so this will be a follow-on to that. And I'm actually doing each video as a separate self-contained entity, so you don't have to necessarily watch all the parts before or after. The downside of that is I have to provide quite a bit of context at the start of each video. So here we go. This is the crate, and what it does is that, unlike the normal standard library's readline function, which is blocking, I needed something that was non-blocking and asynchronous. So I ended up building this thing called Rebel Terminal Async, and one of the things it allows is that once you create a read line with it, let me just show you. This is the examples for this particular repo. You can find them all in the examples directory. So here we have the read line. Oh, oops, it's not. It's actually terminal async. So essentially, you can, this is just a example. So this is simulating you start a command and it's generating output. So this is input. So this is the prompt, basically this greater than thing. And this is line. This is essentially the line buffer. It's a multi-line buffer, so you can actually type things and you can go left and right. It's essentially preserving the state for this what I've typed in here. And what happens is that when you start other tasks, like this one is actually using Tokyo tracing and dumping the traces to standard out. What this is demonstrating is that you can now have one read line which spawns any number of standard outs, and those standard outs can be written to concurrently, and they will not clobber your read line. So and your read line is non-blocking, so it won't block your main thread either. So this, even though it doesn't make a whole lot of sense to see this kind of output, but this is the whole sort of purpose for readline itself, or terminal async, the asynchronous readline. So while I was building that, I figured I would need a spinner component. And so this spinner component essentially is the thing that the previous video that I was referring to. I built out the Braille and the block implementation. So essentially what we're going to do today is take that spinner and colorize it. So instead of just having text animation, there's a PR for that in the previous video where it just essentially adds the ability to kind of cycle through those Braille characters and the block characters. Today we're going to add color to it so that as the animation is happening, instead of just being in black and white, it's going to actually change the color of each character with every tick. Which is pretty cool. So essentially we're going to see this animated color gradient. So to kind of give you a sense of what that even looks like. All this is going to be part of this other repo called Rebel Open Core, which is, this actually has a bunch of crates in it. And this is I'm very passionate about command line interfaces and text user interfaces. And I've been working on essentially building these text user interface libraries, this text user interface library from scratch essentially for the last couple of years, and actually 4 years or so I think at this point. And then let me show you what some of the programs that you can sort of interact with to give you a sense of this these crates from this repo. One of them is called Eddie, the other is called Kitty. So if I show you Eddie, let's see, is there a README? Yes, there is. So this is Eddie, and which is a Markdown editor. And if you look at this heading, it's actually got a gradient. We can't really tell because this, actually this is probably a little bit harsher. There we go, see that? So it's got more info on blocking and thread cancellation in Rust. So essentially these are all gradients. I'm actually running this in Tmux, which is why it doesn't look so good. But if I were to run it in its own terminal window, it would look a little bit different. Let me make the fonts bigger. Let's see, maybe I made it too big. Oops, it's terminal async. Okay, so there we go. Yeah, that looks better. So the gradients, basically what happens is that depending on the color capabilities of the terminal, the the TUI actually, this library, it can go from 24-bit true color to 256 ANSI color to 16-bit color to grayscale to black and white. And you can overwrite it, or it'll detect it. So when it was running in Tmux, it, for whatever reason, it detected that it was not in a true color environment. So I might have to look at that. But that's also great. That's part of this Rebel open core. So everything, it's pretty much built almost everything that I'm going to be using. So it's been a long journey. So if you look at these gradients, like, so if I make this a lot longer, so if I can just copy paste, notice how the color changes. So we're going from this green color to this kind of bluish color to like more kind of greenish blue, and it just kind of keeps going, and then it comes back, loops back around to green. So we're kind of, eventually we'll come back to the start. So that's called the color wheel, and that's something I made for the TUI library, and I ended up using it in other crates. Like there's another crate called Giddy, which uses the TUIfy crate. So TUI is like the full-blown text user interface. Essentially, gives you pseudo graphics capabilities, like a lot of the interactions that you might be used to from graphical applications. The idea is to replicate that in a text user interface that's running in a terminal emulator, which is using VT100 emulation basically. So it's just a bunch of magic with NC escape sequences. I'm like horribly simplifying, but if you're excited about that project, check out this one, the Rebel Open Core repo. It has, and go to the TUI folder, and this will give you, like, this has got a really, really nice README, and it'll explain everything, like in details, like what exactly this is, why I built it, what you can do with it, and it's got really nice examples. So you can even run in the TUI folder, you can say new run examples. So this one actually will show a lot of capabilities of what this TUI crate can do, the Rebel underscore TUI crate. And so for example, this supports something like Flexbox layout. It does animations. So if you see here, this is like, there's a custom markdown parser. There's like custom syntax highlighting. All of this is like written from scratch. It's not using any like CMark pull down parser or anything, or it's not using Syntect. It is actually using Syntect for some things, but not what you're seeing right now. So then you can, this is kind of like showing you that you can do Markdown. It has full support for emoji. And that was like that was a lot of work, because it's yeah, emoji and terminals, it's very difficult to get them to work together. And there's animations, like if you look at this down here, there's a clock. Actually, this is kind of, there we go, this one on the bottom right here. So that's animations. So that's how, it's pretty extensive actually what you can do. I'm still working on it. There's a lot of work to do still. It's nowhere near done, And that Markdown editor I showed you has a lot of bugs. I need to fix like a lot of bugs, but it's getting there. So here's an example of that gradient thing I was showing you. So we're going to be using this color wheel, which is the struct that colorizes this gradient. And the way these gradients work is that you give it a couple of stops. And stops are just like in Figma or some other drawing tool where when you generate a gradient, you have to tell you have to provide some information up front. You have to say, I want a gradient that goes from one color to another color. That's the simplest gradient. And then you have to give this algorithm some sense of like how gradual you want that color transition to be, and those are called steps. So if you have steps, 2 steps, it'll just go from one color to another color very harshly. If you have 100 steps, it'll be much more fluid. Then you also have, I added a whole bunch of other things, like you can colorize one character at a time, you can colorize one word at a time, and all of that is actually here in this color wheel struct. And I'll put links to all of this in the description of the YouTube video. But yeah, go check it out. This is really cool. Like I had to reinvent a lot of stuff to get this to work. And also it's kind of nutty because depending on terminal capabilities, like I was telling you earlier, it can downgrade or upgrade colors. And writing tests for that was a lot of fun as well. So we'll get into that in the testing video, because when we go to test this terminal async, it's gonna be challenging. Okay, so that was a lot of background because to kind of give you some information about color wheel, because that's the thing we're going to be using today to make all of this happen. So just coming back to this is a Rebel open core demo, so examples for a different repo. So sorry about jumping all over the place so there's so many repos. So one thing I wanted to show you with this color wheel is look at what it can do. This is meant to be like a dialog box. So you can type a bunch of stuff in there, and but that is an expression of the color wheel. So it's like rendered the outline it looks like for a dialog box, and then it even does like autocomplete dialog box, which is kind of awesome. Check that out. And there's a whole host of stuff happening here. Like I said, if you're excited about this, please check out this TUI rebel_TUI library. And the README has a lot of information about everything, like how this magic, like how that happened, like how this animation is so smooth, and it's smooth over SSH as well, because essentially I had to build a text-based graphics engine, game engine, to be able to achieve these types of capabilities. So let's just exit out of this. Okay. So now let's go back to where we were intending to be in terminal async. There we go. So coming back, there's a spinner. That's the spinner that we're going to be colorizing. So I don't know how much sense, I don't know that it makes sense to colorize the dots, but I think Braille and Block definitely, they're good candidates for colorization. So to kind of look at how, let's say what the entry points are to this library, let me show you the example that was running just now here. So here we have dots. We're going to be like, okay, I don't think we're going to be colorizing that. Let's just colorize Braille and Block. So what this thing does is that, oh, by the way, I cleaned up this example. So people watching, if you've seen the video where I made the spinner, this example was actually messed up. And it was clobbering the output of, and I thought it was tmux, and then I thought it was this, and I thought it was that. But actually it was eventually I was like, it seems to be messing up everywhere. So I looked at the sample code, the example code, and I was like, oh, I made a mistake there. So what this sample program does is that it creates a spin. Actually, the first thing it does is that it creates a terminal async. And I'm not going to go into terminal async today, but if you watch, I'll put a link to the other video that I did when we created the Braille and Block, and I go into a great amount of detail about terminal async there. But the summary is that that's the entry point to this crate. So you have to use, before you do anything, you have to make a terminal async. And then you have to call the try new, and it might fail, and there's reasons why it fails. Essentially, if if it can't get access to, actually the docs are all in here. So you can see, oh, that is the docs. Let's see, if we go into terminal async, it'll tell you like, oh, why the zoom changed? That's weird. So it'll tell you like, if there's any issues putting the terminal into raw mode or getting the terminal size, it'll spawn an error. When will it, that's the result. But then even if it succeeds, if it's OK variant, it'll still give you an optional, the result wraps an optional type, which is bizarre land. And the reason it's doing this is because this is an unrecoverable error, and this is a recoverable error. So the recoverable error is the thing that's wrapped in an optional, the optional enum, option enum. It's an optional type, I guess. What this means is that if the terminal is non-interactive, that means you're piping into it, piping out of it, or you're running it in a test environment, or you're running it headlessly in the cloud environment where it doesn't have access to standard in, standard out, standard error. It just it can't display a prompt. And it can't give you the read lines, and it can't do anything with standard out. So it just basically returns none. I just wanted to have a defined behavior. I don't know if this is the best approach, but we can change it later if there's other use cases that need to be satisfied. So that's roughly, also another thing with terminal async is that you can lock it. The spinner, what it does, let me show you. So that was this terminal async thing. It makes a terminal async, and that's this thing that says $sign. This is a bit of a hacked up example. If you want to see a real example of this, this is what it looks like. This is another repo I'm working on called, oh, this is the wrong place. Let's do, this is also open source, but this is really early days work in progress. This is the API server. So I'm making a general purpose TCP API server where you can provide your own protocols, and it supports WebSockets, but it's all built from scratch. It's going to also become part of that Rebel. It's kind of like the back end. I'm not sure yet if it's going to be open or closed source, but I'm definitely going to open source this this project, which I'm showing you right now, the TCP API server. I might take this and sort of internally fork it and do other things with it for this backend thing that I'll work on in the future for the Rebel products. But for now, let's look at this. So this is a TCP, and by the way, look, check this out. That's a color wheel again. It's just colorizing a string. So we're going to do that, but you can almost imagine like each one of these is going to be shown, removed, shown, removed, shown, removed, and the delay of 100 milliseconds in between each. And then when you sort of put it all together, it looks like it's animated. So when you type exit, you can see there's two different, I don't know if you caught that. That's the Braille, and that's the block. So that's an example of like, I guess, an application that's using this crate. Because these are just examples, right? So they're just made up to demonstrate certain capabilities, but in quote unquote the real world, this is what it would look like, and this is what the color wheel looks like, just to colorize strings, if you're curious how that looks. And there's a reason for showing this, because we're going to be using this struct in just a minute. So the way this works is that, see the TCP API server, we're going from green to yellow to red. That is not cyan, that is green. This is yellow, and that's red. There you go. So, so the way kind of like I think about these is that you think about the stops and what kind of gradient. This is the hardest part. If you're not a designer, it's difficult. Like, I'm not a designer, so it's difficult. So I usually look at nature as points of reference. So like I'll look at a sunset. Like here where I live, the sunsets are beautiful, and they kind of go from like this blue color to this yellow color to this orangey red color. So you can play with it depending on, you can have like more purplish kind of hues or more bluish hues. This is the hard part. And there's also websites where you can go to find really pleasant gradients. Gradient colors. I used to know some of these off the top of my head, but something like that. No. Sure. What? I think it's this one. Not really sure. But yeah, there's something like you can like, pick from different gradients that you might find pleasant. So if like, for example, if we were to, let's see, because we got to come up with the gradients for our Braille. So maybe this is not a bad website. So let's see. These are just two-tone gradients. I wonder if we can do like three-tone. No? Oh, there we go. These are three-tone. So that looks kind of cool. That looks really cool. So let's see what this looks like. So if I copy that, by the way, I have an extension, VS Code extension that colorizes these colors, so I don't even have to write green. So just remove these comments, which will go out of date pretty quickly. Which one were we at? Oh boy, I forgot already. Maybe it was this one. 4. Nope. Nice. I forgot which one it was. Ha. Okay, let's see which one looks good. Maybe that one? Nope. Seriously? Huh. Oh, there it is. Okay. 5E. And I have no idea what this is going to look like. I'm just going to paste it here for now. And this one. Okay. Who knows what this will look like. And there we go. So there's our stops. This API is very sophisticated, as you can see. Color wheel config, RGB, and this actually accepts a vec of colors and a whole. You can actually just read the docs, and there's other examples in the repo in this Rebel open core, which goes into great amounts of detail on how to use it. You can give it like different gradients. You can say this is the RGB, the true color gradients. You can say, okay, if you're not in true color mode, it'll automatically translate it to 256 and automatically go to 16 and automatically go to grayscale and black and white. But you can explicitly say, okay, if the terminal capabilities only support 256, then use this other stops that I've given you. So you have complete control depending on the the terminal capabilities. So it's ridiculously overbuilt. Absolutely, completely bonkers overbuilt. So let's see this. See that? That doesn't, whatever, it looks different. But you kind of get a sense for how this works. And you have to play with it. You say, well, okay, what happens when I say color wheel speed? Or let's see what the variants are for this enum. Okay, it was medium. So what if we do slow? And tweak one at a time. I would not recommend tweaking all of these in one go because you're like, which one did what? I don't know. So where is, oh, here it is. So let's run it again. So it looks to me a little bit smoother than before. So maybe that's not bad. So essentially what it did was it really slowed down the number of how the colors were being transitioned. They're not so abrupt anymore. And steps means like how smooth do you want it? Do you want this like beautiful like super, if you want a really smooth gradient, you have to do like larger numbers. And if you want very abrupt gradients, you can do smaller numbers. So let's see. There you go. Now it looks a bit more fluid. So if you want it to be like totally like almost seamless where you don't want it to be such a drastic difference, then you can just make it slow and make this number really long. So you can do like 150. So it'll like smooth it out even more. So let's see what this looks like. See, now it almost looks like one color, but it isn't. So it depends on how subtle, what level of subtlety you're going for. Like, do we really need like 3 colors here? No, because we barely make it through 2 colors. And so you have to, play with it. It's fun. So like if I wanted to make it more smooth, then essentially there was no reason to even have a 3-color gradient. Maybe we can look at some fun 2-color gradient like this maybe. And then, oh, actually, you know what? I have clipboard history. I don't have to forget. So we can do this one. And we can do this one. Clipboard history for the win. And then if we run this, let's see what that looks like. Oh. So as you can see, what I think it's going to look like in my head doesn't necessarily translate into what it actually looks like. So I don't know, play with it. So let's go back to maybe the previous iterations. Who knows? Maybe that looked good. No, maybe that one. Let's see. So you can play with this for as much time as you have. It's fun. Okay, so I don't know if this is better than how it was, but whatever. Let's just leave it. And what I will do is put a link to this here. So we can see all the colors that we can get from here. Let's do this. Nice color gradients. Okay, so this is a different repo. Again, we're not going to be working on this, so, but it's actually good. We're going to be using this code. And to kind of walk through this a little bit, first we got to make a color wheel, and we got to tell the color wheel how we want it to behave. So this is the plain text without the colorizing. This is the colorized output. So actually, let's do medium, because then we can see the second color as well. Because I don't know, looks the same. I have a oh, there we go. I have a terminal tmux session that's compiling this in the background constantly. So there you go. Now you can see the third color, which is pink. If you wanted to see it even more drastically, you can do like that. Then you'll see it'll go the other direction. See, it goes completely bonkers because what it's done is cycle through the color wheel probably twice. So we don't want that. We want medium, and we want maybe 70. That's good enough. Like, I'm sure, like, if there's designers in the audience who are like, you know what, I know exactly the right kind of color, then I'm open to suggestions. We can make this nicer looking. You know, it's kind of weird. These colors end up matching these colors, so that's not bad. It's like on brand, so to speak, which is cool. Okay, so that was totally random. Or maybe it was subconscious. Let's see, because I do also have custom key maps for my UHK keyboard. This thing, which is awesome. That's the clicking you're hearing right now. This thing is great. It's so cool. And the clicking is from this trackball module. It's not a mouse. And that all these noises are from a trackball module. Hopefully this won't break anything, but this is the one half of the keyboard. So as you can see, it's got a palm rest. It's got all kinds of cool. Where's the camera? What? Oh, that's weird. Oh, my hand was in the wrong place. So yeah, and these come off. So these modules are detachable. You can do all kinds of cool things with them. Anyway, so that keyboard. Oh, now I gotta put it back together so I can type. Let's see if that worked. Yes, I don't think anything crashed. Okay, that's good. Okay, so this. Okay, so where were we? All right. So let's see. So maybe these colors, because if you look at my IDE theme, they're also like kind of similar in a way to that keyboard. So maybe everything is just kind of like driving towards that same color combination subconsciously. Okay, so the first thing we have to do is decide what the colors are, how many stops, how many steps, and the smoothness. Actually, this is also smoothness, to be quite honest. This is, they're both gradient smoothness. This is inaccurate to say this is just steps, is also gradient smoothness. Anyway, but, so let's see. Maybe this gradient smoothness transition speed, and this is gradient smoothness, not steps, but maybe actually I can't come up with a better word, but they're both related to gradient smoothness. So I don't know if this is helpful. Okay, so then once we have the color wheel config, we have to, there's this color wheel struct. We have to make a new color wheel. And it has a convenience method called colorize into string. And it has a whole bunch of other convenience methods. It can colorize into something called NC style text, which is a whole other thing. There's another crate in here. I don't know if you remember that 2ify thing I showed you, Giddy. Oh, I didn't actually. So this is Giddy. Giddy is another program that uses not the 2i crate, but the 2ify crate, and so you can do stuff like this. Giddy branch. It's like it's meant to be like a nice friendly wrapper on top of Git commands, because I don't know, it's difficult to remember for me anyway. A lot of these Git commands, so it's like what are the normal workflows? They're kind of like encapsulated in Giddy commands, and they turn around and run Git commands under the hood. So you can delete, check out new. These are all using this thing called 2ify. So yeah, check it out later if you like it. So delete and then Control C. There you go. So I don't know if you noticed, look, color wheel. And I should really stop using tmux sessions to show this. I gotta look into that. Let's see, this one, we can say gitty branch. Yeah, same thing. Anyway, so, okay. So the color wheel struct has a colorize into string. And that's used by this giddy thing that I was showing you. And then, and by the way, you can get Giddy and Eddy using cargo install rebel commander. They're on crates.io. Okay, so we take the color wheel struct, give it this config, and you can give multiple configs. This is the true color RGB config. You can have like other configs for, let's see. This is kind of crazy. This is the lolcat configuration where you're telling color wheel, hey, surprise me. It's kind of fun. So it's inspired by lolcat. So I wanted to put lolcat as a function in every program, everywhere, all the time. So instead of saying echo foo lolcat, which is, I don't know if you can tell it's colorized. That's kind of like the intention behind this RGB random. It's like, just make me a random, you know, make me a random color gradient. Surprise me. There's also lolcat, which is kind of like similar to this. There's a whole other thing called lolcat, so that is more lolcat-y, but it all ends up using color wheel. It's just convenience. If you're thinking of building more like a lolcat in Rust, just you can use this. If you're trying to do something a little bit different, you can use this. This gives you more control, and you'll see like color wheel speed and a whole host of other things. Oh, stops, speed, and steps. That's, why don't I just use my own documentation? So this is stops, speed, steps. There you go. That makes more sense than the other one. Okay. Then, okay, so let's get out of color wheel. So there's a lot of stuff happening under the hood. So we pass it a color wheel config. Then we call colorize into string. There's other colorize functions. Functions or methods? Methods. So this color wheel thing actually has some state. And it was my inspiration behind it is an iterator. Every time you call next, it gives you a different color. And what color you give it depends on these policies. So you can say, because it maintains an index of where it is on the wheel. So once the wheel has been generated using the config, it remembers it. And then it goes, oh, the last time you asked next, I gave you this index. So at some point, it'll go next, 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 and then it'll dunk, jump back around to start, next, 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 dunk, jump back around to start. So it's stateful. So if you drop this, then you'll get a new one every time, and it's not a problem because we have the set start, middle, end. All this configuration will generate the same color wheel every time. So that's not the case if you call random though, because we don't know. So in this case, what it's saying is reuse existing gradient and reset index. What this means is that it's as if Like make me a new one of these every time and reset the index every time you call color into string, but reuse it to save, for performance reasons, because it can be somewhat CPU heavy to generate these gradients, and because there's like, let's say there's like 100 of them or whatever, like that's some work that needs to be done, and it can be memoized, so this memoizes it. There's other policies you can give it where it won't memorize it. Remember I mentioned this was over-engineered to the infinity and beyond? Yeah. And then text colorization policy is you can color each character or each word. And you can go even more nuts. And you can say, you can give it a style. So you can say that colorize it and then also bold it or italicize it or whatever the style is. The style can be anything. Like it's essentially inspired by CSS and it's part of the TUI stuff. It's kind of like imagine if you had CSS in the terminal, but like not as complicated and confusing as CSS specificity, like something that made more sense. That was the inspiration anyway. In the future, I don't know, I might like veer away from CSS. Maybe make something more intuitive that kind of achieves the same result. Okay, so now we're going to apply our knowledge of color wheel in our spinner. So let's look at the spinner code real quick. So let's add the color wheel to the spinner. Let's look at the spinner code real quick to get started. So it looks like the main entry point for spinner is, I think, try start, yeah. And then I actually cleaned up this code quite a bit, and I refactored all the implementation details around like the differences in like the rendering and the painting. I moved it all into this other module called spinner implementation. So the actual spinner code got pretty simple. So it kind of goes like, so when you first start it, it tries to start a task because it's going to, on an interval, it's going to do stuff. And what it does is based on the style, it renders the tick, renders on every tick, and it paints it. And then I think that's pretty much it. And then when you stop it, it aborts it, and then aborts this task. Yeah. That stops the painting. And then it just, for the final message, what it does is it does render final tick and paint final tick. So all of this is in this file, spinner render, and there's like a spinner constants, which has like what is the array with the braille dots and block dots and so on, and all the times and stuff. So this is the spinner style, which is just an enumeration of the different types of templates and the color options. And what we're implementing right now is the color wheel. This is what we're doing. So you can look at spinner render. Okay, so let's look at this code. So essentially, we know there's a trait too. So there's really like on every tick, there's like the render function that gets called, which produces a string. That string gets painted. Similarly, for the last tick, meaning that this is when the spinner has started, it's doing this on an interval. When the spinner is finished, this is what happens. So it does a render final tick and it paints the final tick. And there's a loop that simply increments a counter, waits for an interval basically, and just calls render tick and paint tick. So that's what these parameters are. The arguments are whatever's passed by this spinner.rs. So I think where we want to put the colorization is in the render tick. And I think because of the way the color wheel is used, color wheel I think has some state information. So I think we'll need a color wheel struct in spinner style is my guess. Yeah. So let's see, what is the best way to handle this? So essentially, oh, I actually have some to-dos here. Oh, okay, that's handy. Oh, okay. So basically, this is it. In the render tick, because I think render final tick, we don't doesn't really matter. Like we don't really care about colorization. It's just got to have different colors in the render tick. And in render tick, I think the thing we have to render isn't the whole thing. It's just this like this braille dots, whatever that is, and the block dots. So essentially, the colorization is going to happen in here. So it's really more like this. It's more like so once we've retrieved so we could say let output symbol. So we can do like this, and then here we can say output symbol and message. Maybe this is easier to read. And here we can do something similar. Output symbol is that, and then here we say output symbol, and here we say message. Get rid of these. So now what we want to do is colorize this output symbol. So what we want to say is if let, oh sorry, if actually let's see, nope, style color. So I don't see style, maybe it's in self. Let's see. And then we can say let self.style is self.style. Nope, there's no style. I thought there's a style. Oh, color. Okay, so we can say color. Color, and then we can say match self. Oh, actually, this is, well, let's do this. Match self color. And what I want is, if it's none, I don't want it to do anything. So it's really, and then I can tell, there we go. So, okay, so here what we want to do is we want to colorize. Actually, we want to do the same exact thing here. So what we have here is spinner color. Let's go look at spinner color. Oh, I think I know what we have to do. So spinner color, when we create a spinner color, we have to provide a so maybe this is not color wheel, this is color, and then it's going to take a color wheel. And oops, what is this? What do you mean? Oh, I don't think I've imported color wheel. Let's see what crate this is in. This is in rebel underscore TUI. Oh, so basically we need to bring in the TUI crate just so we can get the color wheel struct. Then we wait for Rust Analyzer to do stuff. It's doing stuff. Oh, there we go. So we got the color wheel. So now, okay, that worked. So now whenever somebody specifies a style, which, oh, color wheel is no longer copy. Because color wheel is not copy. Oh, okay, then we just drop copy from all of them. That's fine. Let's just do this. It's not really that interesting for them to be copy. Clone is fine. Okay, so what this means is that if you want to specify, so let's look at where this code is used. So when you specify style, and in the style you want to specify that color is used, then in that color you have to tell we have to provide the color wheel that's going to be used. We could make this an optional, but I think that's unnecessarily complicated because for our purposes, we will need a color wheel every time. Let's see what errors we have. Cannot, oh yeah, that's right, because this is now clone. It's no longer copy. Oh right, this is not a thing anymore because now it's gonna be color wheel. Color wheel. Then this is going to be clone because no longer copy. And then, oh, this one, oh, okay, we need to use, whatever, we're not really using it right now, but we will soon. All right, that sorts out those errors. Okay, so now, let's, in the example, let's see, where's our example? So in our example, we have example with concurrent output. Oh, so okay, it's only specifying the template. It's not specifying the color. So maybe what we should do is for, let's do one at a time. Let's do Braille first. And so for Braille, maybe I want to provide a spinner, is it spinner style? No, spinner color. So here, I need to provide, this is where that, this code comes in. So just copy and paste that. So essentially what we want to do is we want to create a color wheel. And actually I'm going to put this in a separate, this one is going to go elsewhere. So here maybe we just say color wheel. And actually what we want is this. We want to say this. And then this will be color wheel dot because it's already been created. But this will go like down here somewhere. Actually, no, this won't go in here at all. This will go in the implementation of the code. Okay, so why is this red? Oh, I see. Spinner color. There's two variants. Oops. So that's that, and then I think here is where that goes. If you want to think of it that way. And it's not going to be Unicode string from TCP API server. It's going to be Unicode string from message. And we have to figure out what this is going to be. It's probably not going to be these policies, but we'll come back to it in a minute. Let's see what other errors we have. What's the issue? Oh, right. This is, oops. So maybe what we can do is just not pass this as well. Let's make this a function. Say fn let's just make a color wheel. And then what we want is this. And we want to return it. So then we can say create color wheel. Oops, create color wheel. Right, that'll call that function. And then don't know why this became. Oh, it's the same function. That's why. Well, this doesn't make any sense. I'm going to clean this up later, but here we're just going to put this everywhere. Even though for dots, it doesn't make any sense because it doesn't use color wheels. But I will, after this, in a later iteration, I'm going to turn this into a PR, and then I'm going to clean this up later in that PR. But I will not do that in the stream. There we go. So we are just making a color wheel, and we are using it in our example. And here, let's see. So we need to use this. You know, we can't just like do like. There you go. So essentially, when this function, which gets called 3 times, once for dots, then rail, and then block, it also gets. I mean, I could just technically speaking just make the style here instead of passing 2 of these arguments, so it doesn't really matter. That's just a style preference, because either ways it's going to do the same thing. Basically, I can either, instead of passing 2 args, I can just say style. Spinner style, I don't know if that's easier to comprehend, and then, you know, ditch these 2. And then this would just be style. And then I think that just says style, yeah. And then here we would have to basically do like this. Create a spinner style out of each one. So this would be like, the first one is template. And this one is color. So we'd have to do something like that. And then we can just say, so it's going to be braille. This one's going to be block. Okay, that works. Okay, we still have to implement it. And let's go implement it. So that just took care of like passing the style into the thing. Okay, now it needs Unicode string, which is, I'm assuming, from a different crate altogether. Yes, it is. That's from Rebel RS Utils core. So let's go bring in Rebel RS Utils core. That Unicode string is needed for any string manipulation in the TUI crate. So it works with emoji is the short answer. There's all kinds of information about like this one, the grapheme clusters, and this is basically the module from in which Unicode string exists. And there's the TLDR is that when thinking about normal like ASCII or ANSI characters, which think like, okay, like H takes up 1 byte of memory, and it takes up one display width, whatever the unit is in a terminal, so the width of 1 character. An emoji, on the other hand, you can even see here, it's almost like it's like twice the width of H. So the grapheme cluster size is 2, and the byte size actually is more than double, 4 times. So there's all kinds of reasons. Like you can't just index into an array of like in a string if it's got Unicode characters. If you try to do an index halfway through an emoji, you're going to get a panic. So this module and Unicode string ensures that that never happens. So it's just a really handy. It's just a drop-in replacement for string. So we need to bring these in and bring those in. All right, cool. So if the color wheel is this, so what we're trying to colorize is not the whole message, it's just the output symbol. And what we can do here is, so if let create blah blah else. So that means that, there we go. So, and here we can put like, and we can do maybe like this. So essentially, and instead of output symbol, we're doing it. This needs to be mutable, so we can put mute here. There we go. So essentially we have, and this is called, yeah, so reuse existing gradient and reset index. So I don't think we want to reset index. Let's see what other options we have. I'm just going to say reuse existing gradient and index. Okay. Let's just see if this works. And this one is going to be a no-op. Instead of a to-do, I'm just going to say forget to implement this. So let's see if this colorization works for Braille dots. Just run the example. This we know it's going to work because we haven't really changed it. Dots is the same, but let's see if... Oh, look at that. And it looks like it's the same color. So that didn't work. And it bugged out in other ways. So let's see what's going on. Maybe this was... Let's go back to whatever. I need to read up on what, or remind myself what this does exactly. Let's run it again and see what happens. I'm going to change the example so that... Oh, it's still blue. Huh. Okay. Actually, let me change the example real quick so that we're doing Braille first. Okay, so... Okay. So it's just remaining blue. Okay, so we're clearly not doing the right thing here. So if colorize into string, so what I can do is this. Let's ask the color wheel. Let's see, what is the, see how colorize into string itself works. So you give it a string. Oh, I think it's colorizing the string. That's why it's always blue. So it's like given a string, it'll like colorize the string. We don't want this behavior. We want a different behavior. So let's see how this is implemented. So it generates a gradient. Okay. Then what happens after that? Generate a gradient, and then there's something called reset index. Okay, so let's see, I haven't looked at this code in a long time. Next, I think we just want next color. Yeah, we just want next color. So let's see how to call this. Okay. So let's see what this does. So it makes, let's see what this function does. Generates, says generate style texts. Okay. Let's see. Let's go find the next color. Let me see if I can find some better examples of this. So this is like maybe next background color. Okay. I see. Generate foreground color 4. Oh, this is something else. Okay, we just need next color. Okay, so Generate style texts. What does it do? Okay. That is way overkill for our needs because all we need is the following. We just want, or let's say next color equals color wheel.next color. And then what we want is that if let, so then we have a TUI color, and what we want to do is we want to, the TUI color, we want to turn this TUI color to a cross-term color. Okay, which are provided by two cross-term color. Okay, so let's do that. And we want next color. And what this does is that it gives us a cross-term color. And we're using cross-term right now, so that's why I want to do this. But I'm pretty sure there's a way to just two-string it and get like the ANSI escape codes for it. Maybe let's see, to cross-term color, from cross-term color. Convert RGB to grayscale, to ANSI grayscale. Okay, so we're gonna get a color. And then that is one of these. And then this has, let's see, try from, I'm trying to see how to convert a color, like use the color struct. Let's see, gray.parse, no. Then color from, wonder how to use this color to actually, let's see, it's from string. Not really helpful. Let me go look at the cross-term docs, actually, docs.rs, cross-term color. Okay, so these are different variants of the color. Okay, how do I use them? Color parse ANSI. Okay. No. Didn't say how to use the colors. Okay, after some searching, I think I might have found the answer with cross-term, which is this example. So given a color, we might have to use this. So basically, we have styled content would be, what is that code? Style. Style is coming from, let's see, from cross-term. And we want with color is, on means I think background. So what we want is it, and then that becomes the styled color. I'm sorry, the styled content, and then we can just format it. We don't need this anymore. And then let's go look at the imports. What is the issue with all of this? I think, what is it saying? Oh, so we imported the wrong things. So it looks like we need to import different things. So let's do that. Oops. Let's see. This one and that one. Okay. It's colliding. Then let's see. Did that fix the problem? Cross term. Okay. So let's see if that went away. Oh. What is this? Width is not working. So if we have a color, let's see. So logic goes, if we have a color wheel and using that color wheel, we get a color. Then, actually, let's do this. Then we take that color, we convert it to a cross-term color. Okay, let's see what's going on here. So we got the color and convert it to a color that can be used, a cross-term color. Then use cross-term to, actually this is not, basically paint the output symbol with the color. And what's the problem? Oh, I see. Interesting. Cross term. Oh yeah, of course. This should be styled content, not the color. So this is color. So I see. So this is pretty. Let's see if this is easier. Not really. So this is like. Okay, so this is saying that let's see what the other variants of smear color are. None. Oh, okay. So this is saying there we go. So okay, I see. This is like, wow, that's quite complicated. Let's see if it works, because we're saying if there is a color wheel in the spinner color, in the which is in the style, then we use that to get the next color in the color wheel, and then, and I think this is stateful because this is coming from self, and it's in there. Yeah, that's stateful. Okay, let's see if this works. So we get the color. Convert it to the, let's see, maybe next color. We convert it to a cross-term color. This is, well, then we use the style function of cross-term to colorize the output symbol. And then we generate the, okay, that makes sense. I'm sure there's some cleanup that can be done here, like for sure. So let's run this and see what happens. That doesn't look like it colorized anything. Huh. I don't think so. It looks like black and white. But we do have self.color here. Let's see. Okay, let's do this. Let's just see what self.color has. Just real quick. It's color wheel config. Okay, so it has a color wheel. Index is 0. Okay, that's good. So that means when it comes down here and it's in Braille, which is here, the color wheel got created. So that's good. We're actually in here. Let's look at what this next color is. Curious to see if that's producing any output. None. Okay, that explains a lot of what's wrong with it. Interesting. So maybe the color wheel didn't get initialized correctly. Yep, because I think I remember in some of these examples, before next to color was called, there's some other colors like generate color wheel. Yeah, I think this didn't get called. Maybe. Get index. Let's see. So color wheel. So lazily create a color wheel does not compute the gradient. Okay. Oh, heavy lifting is done when generate color wheel is called. When you use colorized, it will also call. Oh, okay. So we need to call generate color wheel. Okay, I had a feeling I was skipping a step. So what we want to do then is call that here. And then return that. So basically, when we create the color wheel, we are making sure to call generate color wheel so that when it does next color, it won't be none. Okay. Interesting. It still looks like it's the same color. Like, doesn't look like next color is doing anything. It could also be that 70 steps is too much, and maybe we just want like 10 steps, because it doesn't get, if you think about it, it doesn't get called that, like, doesn't, the number of ticks or iterations is not that many. So maybe we'll be able to see this. Let's see this. Nope, it's still blue. That wasn't it. Okay, let's see what the configuration is. Fast. Generate color wheel. Okay. Okay, let's go see. Color. Next, let's see what next color does. Reset index. Can I set the index? Reset index. Something called self index. What does next color do? It updates the index. When it reaches the end of the gradient, it will flip direction and go in reverse. Okay. Oh, this is what it's saying. If the gradient is not calculated, that's why it was none, which is fine. So it goes early return of lolcat. It's not lolcat. Determine if the index should be changed depending on speed. Okay. Interesting. Should change index. So it's saying next color this is basically the same code. It goes get the next color. If there is a next color, then do we color RGB value basic? Okay. Interesting. Okay. Color each character. That's what we're doing. Generate style foreground color for next. It should be working. It goes self next color. Don't understand. Yep, it's just next color. Okay, let's just see what's going on. So here, no matter what, next color seems to be stuck in that index. So let's see if there's a get index or something. There is a get index. Okay, let's see if the index changes. So we can do color wheel. That's weird. Oh, it's get index. So we should at least see the index change. Nope, index is 0. Okay, maybe I'm not understanding how the color wheel works. Seems to be resetting itself every time or something. So really, what I want is every time the tick happens, I want it to get the next color from the color wheel. Maybe the color wheel is being created in the wrong place. Oh. So what if for spinner style, maybe, okay. Maybe instead of, because we're in spinner style itself, so maybe spinner style needs to have the color wheel. so that it's mutable. I think that's a problem. Okay, let's just see how we pass this in. I don't think this is correct. The spinner color. I don't think we can put a color wheel here. I think that spinner style will have to have the color wheel, which is going to be an optional. And the default is going to be no color wheel. So if you specify spinner color is color wheel, then it's going to go get it from spinner style. So let us see. What is this doing? Oh, right, and this one is going to make a color wheel. So here we can specify not that. This is going to be color wheel. And that. So get rid of this and add that. Here, get rid of this. Add that. Okay, so that I think takes care of. Okay, let's test this hypothesis to see if it's going to work. So yeah, we're not going to be able to get the color wheel from here. But we can get the color wheel from self. Actually, why am I putting the... No, not clone. Oh, it's optional. Okay, so we can say match self dot color wheel. This is color wheel. So if it has a color wheel, do this. And here we can just say and let's see, what's the problem? Oh, right. So what is this? Oh, yikes. Oh, so render tick. Oh, whoops. Why is it cloning? Maybe this is the problem. No, it's not the problem. Well, this is nothing. That's not the problem. This is like at the very start, like try start task is cloning the style itself. This only happens once because it gets cloned and then passed into this Tokyo spawn. So this instance will be updated as expected. Okay, that's not the problem then. What else we got? Cannot move. What? Okay, let's see if that does anything. Yes, it does. Okay, that was it. The colors are changing, so yay, we can get rid of this, and hopefully that will... Actually, I'm just gonna stop running those other examples because they're taking too long, so I'm just gonna comment those out. Okay, now let's do this. Colors changing, colors changing. Oh yeah, they're changing. All right, we did it. Okay, so wow, that was painful. But I guess such is life sometimes. Let's see. So the problem was I had put the color wheel in the wrong place, and it wasn't being updated. It was supposed to be in spinner style. I messed up and I put it in some place where it doesn't. I put it in here, and that's not the right thing to do. This is the right thing to do, and so yeah. So now it's just like a matter of cleaning up the this code. As you can see, this is quite quite gnarly, and then this needs to be flushed implemented as well, and then the example needs to be updated. So what I'm going to do is create a PR for this, and I'm going to wrap the video here because this has been already an hour and a half. I had intended this to be for just an hour, but this has taken longer. And while recording, there were like people sawing outside, which was unpleasant. So I had to pause the recording in a couple of places if it looked really strange. So yeah, if you like this style of video, please give me a thumbs up. Please subscribe. It helps the channel because I'm trying to grow this new channel out of nothing. And also developerlife.com. This is a video channel for developerlife.com, which is my website which I've been running for over 2 or 3 decades now. And it has a newsletter. So if you subscribe to the newsletter, you'll get notifications for not only tutorials, but also videos when they come out. Thanks again for watching. I'll clean this up, make it into a PR, and put in the description for this video. And yeah, hope to see you on the next one. Take care. Bye-bye.